summer school. And before the beginning, I have one thing to say. Now we can enter both buildings, Histech Digit and Histech Arctic as well. Security guards have our list of participants. The first lecture for today is Motivational Systems in Cognitive Architectures by Ricardo Gudwin from University of Campinas. Ricardo, go ahead.
Thank you. Yeah, I will take the microphone. Hello, good morning to everyone. It's my pleasure to be here today. I'd like to thank Professor Alexander Panov for inviting me to come here to talk a little bit to you today. My name is Ricardo Gudwin, and I am a professor at the Faculty of Electrical and Computer Engineering in the University of Campinas in Brazil. And I run this group for research on artificial cognition. So the idea is to try to understand how cognition happens in animals and in men, and try to create computational versions or computational algorithms for these cognitive processes. And so I will be trying to talk to you about this field of cognitive architectures. Well, this is a summer school on artificial intelligence, and we can see that cognitive architectures are a part of artificial intelligence. If you go to traditional books like in Russell and Norvig on artificial intelligence, you see that he divides artificial intelligence in different fields, and one of them is trying to understand how intelligence can happen in a cognitive way. And this is exactly what we do in cognitive architecture. So the main idea is that we have here an intelligent agent. This agent in some way is connected to an environment, and it's able to sense this environment and perceive things happening in the environment. It needs to then think in some way and actuate back in this environment. So the idea is that this intelligent agent is a system that is capable of sensing an environment, creating a model of it, and acting intelligently on it. And basically the problem that we want to address with these cognitive architectures is how we control these intelligent autonomous agents. The idea is that these agents are not anymore just tools that we are using. Just like, for example, I can have an intelligent tool that is in my GPS in my car that creates a path for me to go from where I am to where I want to go. This is just a tool. We are talking differently here. These agents, we want them to be autonomous, to be completely autonomous and work by themselves. And because of that, we need a cognitive architecture on top of it. But what exactly is a cognitive architecture? We can understand a cognitive architecture as a general purpose computational architecture, providing the basic infrastructure to the construction of artificial agents. And how do we build these cognitive architectures? We get inspiration on what we call cognitive models of human mind. We go into psychology, we go into the philosophy of mind, we go into biology, we go into neuroscience, and then we try to implement computational versions of these cognitive abilities. And among them, we can say, for example, sensing, perception, attention, emotions, memory, decision-making, reactive and deliberative behavior, motivations, learning, and in some cases also consciousness. There is a strong field of people talking today about machine consciousness. We are trying to use this in our research. Language, and mainly the evolution of language, so how can we possibly talk to these intelligent agents. Metacognition, the ability to observe ourselves when we are thinking and then use this for some purpose. Social cognition, and other kinds of cognitive abilities. Well, the field of cognitive architecture is not exactly new. we are today talking about almost 40 years of cognitive architectures. Here we have a great list. We have some people working specifically on cognitive architecture. There is a society, the BICA Society, that is basically addressing this field of biologically inspired cognitive architecture. And these are just an example for you to understand how many different cognitive architectures are being available. I put here 4 of them in red because these are the ones that we have make a further investigation on them, mainly because they have their software code available in internet, so everyone can download this code and can use this code for their purpose. So this is the reason that we chose these 4 and put them in red. Well, just for you to take an idea, this is the cognitive architecture Clarion. I'm not going to enter into the details, but if you have questions later, you can address them to me. This is another example, the LIDA cognitive architecture. The MECA cognitive architecture, which, by the way, is a cognitive architecture that is being developed by our research group, and we are trying to use it in different applications. We have used it in the traffic control. Now we are using them for controlling transportation robots in factories. Okay, so this is SOAR. SOAR, together with ACTR, is one of the oldest cognitive architectures. SOAR, for example, is available since the 90s, so more or less 40 years from now. Well, some of these cognitive architectures are more symbolic in the sense that they are based on rule processing, so they are rule-based systems. Others, like Clarion, for example, are more connectionist. They are using a lot of neural networks inside it. But most of them nowadays, they are what we call hybrid cognitive architectures. This means that they are using both rule-based systems and neural networks together and in some sense interconnected between each other in order to work and to operate. There are also 2 different kinds of software implementations for these cognitive architectures. There are what we call frameworks, and for example, LIDA is a framework, SOAR is a framework, but Clarion is a toolkit, and MECA is also a toolkit. The difference between them is that when you have a framework, you just start the framework, and you need to make a configuration of this framework before, but that's it. The framework works by itself. If you have a toolkit, you have a different strategy, and in this case, you have many components that are available, and then you need to mount your own version of your cognitive architecture using these components that are available, and then you can use this cognitive architecture. Well, thinking about how all of them operate, we can say that they have what we call a cognitive cycle that repeats itself, and this cognitive cycles is typically something running from 50 milliseconds to 150 milliseconds. It depends a little bit on the cognitive architecture. And it's a cycle that starts from sensory information. It performs something, and then at the end, it makes an actuation at the environment. And this is the most important thing for the topic that I want to address here today. This is just an introduction for you to contextualize on the field of cognitive architecture. But today I'm going to talk about behavior generation. What is behavior generation? Well, we want these agents to act in the world. They need to have some kind of behavior in the world. So behavior is anything that we can call a sequence of processes within this cognitive cycle which ends generating the final agent's behavior at the environment. And then we need to ask ourselves, well, how we, human beings or animals or intelligent agents that we want to build, how do they generate this behavior? What are the premises for them to create this behavior in the world, okay? And in order to give an answer to you, I will go into a kind of a more philosophical premise. And Charles Sanders Peirce is the American philosopher that is the creator of what we call semiotics. It's different from the Russian tradition on semiotics that has a different background, but it's exactly the same. So we want to understand how things can be used to represent other things. Basically, this is what semiotics. And well, these are very high-level abstract concepts that are not easy to understand. If you are reading the definition of each of them, probably you are feeling, oh, I'm in the wrong room. I'm not understanding this too much. But you will see that these three premises, firstness, secondness, and thirdness, are the guide for us to understand the different kinds of behaviors that we can have in our environment. Okay? So firstness is the mode of being of that which is such as it is, positively and without reference to anything else. The idea of first is predominant in the ideas of freshness, life, freedom, novelty, creation, originality, potentiality, randomness. So the idea of firstness is that something can come from nothing. Okay? This is just like randomness. Okay? I turn a coin, I turn a dice, and then there comes a number, there comes a piece of information that is completely new. Okay? This is what Peirce calls firstness. The second idea is the idea of secondness. And I am not going to read everything here, but the idea of secondness is the idea of causality, the direct physical causality, efficient causality in the sense of Aristotle. The idea that one thing gives rise to another thing. Okay? So that one thing is a direct function of some second thing. This is called the name secondness. And the most interesting of them is thirdness. Thirdness is quite difficult to be understood. It took a lot of time for me to read this and say to myself, oh, I can fully understand that. Thirdness is the idea that something is a mediator to something else. And you can see that if we are talking about representation in which you want to use a sign to represent something else, you can see that it is in this mode of thirdness. But we are not going to use this right now for semiotics. We are just getting inspiration on that. Why? Because we want to classify behaviors. Okay? And if you want to classify behaviors using these three ideas of firstness, secondness, and thirdness, we can see that we can have three different kinds of behaviors. The first one that we call in here original behaviors, the second one that we are calling reactive behaviors, the third one that we are calling motivated behaviors. Well, what are original behaviors? In principle, this could be, for example, random actions. I just use a pseudo-random generator, for example, in the computer, creates a lot of random data, okay? And use this data to act in the world. It is possible. It's not going to lead us too far if we use only original behaviors. But you can see that for us to understand and to experience our world and to understand how things work in the world, these original behaviors, they are very important. Because at the beginning, what we are doing is that we are trying random behaviors. Imagine a baby making its first movements in the world. What the baby is doing original behaviors, okay? But not only purely random actions. We can have, for example, random modifications of already known actions. So I have already learned some behavior, and then I make a small change in it, and it creates a new behavior. That is not so far from the old one, but it is new, it's original, okay? It can also be the random combination of already known actions. So I have two or more actions, I coordinate them, I randomly put them together, and what we have also and original behaviors. Okay? So original behaviors is one of the kinds of behaviors that our cognitive architectures can exhibit. Okay? Well, what about the second behavior? This is the most known to us kind of behavior. These are the reactive behaviors. Most of the things that we do in computational systems nowadays are just reactive behaviors. For example, if I use a neural network to create a behavior to act in the world, this neural network is doing nothing more than a reactive behavior. If I use a fuzzy system, for example, it is just a reactive behavior. Any kind of equation that I could write like this, a behavior is a function of a sensory input, is simply what we call here a reactive behavior. And it's interesting from this reactive behavior that they don't have internal states, so it's a direct function. I have an input, I get an output, and so it is a reactive behavior. The interesting thing about reactive behaviors is that they are blind to what they cause in the world. They are what we call a pure mechanical reaction. It's just reacting to something else. Okay? And it's interesting because now we have at least two different kinds of behaviors. You have original behaviors, you have reactive behaviors, and so if we try to combine those two, original behaviors and reactive behaviors, we can make interesting things, okay? But this is not enough. It's true, only with these two we can make very interesting things, but we can do more, and this is exactly where we want to reach. We want to talk to you today about motivated behavior. And the first thing for us is to clarify that motivational behavior is a completely different categorical kind of behavior than original behaviors and reactive behaviors. They cannot be confused. And it's very easy to confuse motivated behavior. But let's try to understand better why we need to categorize them. Well, they are not randomly generated behaviors, neither pure reactions to sensory inputs. The difference that we have in motivated behavior is that they have a finality. They have a future to be reached, a goal. So, if I, for example, if you not liking my speech and you start throwing papers in me, okay, I can reactively move myself, okay? This is not going to be intelligent in the beginning. It's just a reaction. But if I want to address a future, to reach a goal, then I will use a motivated behavior. Well, the existence, the pure existence of motivated behavior as a different categorical behavior from the other two is a complex discussion in philosophy and in biology. For example, the biologists, they discussed for a long time if you have a cell, imagine a small cell like an amoeba, okay? It has their pseudopus moving around, and there is some food at the environment, and then this cell just embraces the food, okay? The biologists are discussing, well, is this just a reaction to the presence of food? Or there is really a motivated behavior? The amoeba is trying to embrace the food and push this food inside to it. You can see that this is not easy to answer that. It's quite complex. And for a long time, there was a discussion if there is really this kind of motivated behavior. Okay? This discussion started in philosophy with Aristotle's final cause. Aristotle was a philosopher, a Greek philosopher, that created a theory of causality, and among them there was one kind of causality that was called final cause. The problem with final cause is that from a philosophical point of view, it led to the concept of teleology. And teleology is complicated because We need to think about if there is a cause in the universe, if the universe is just something that emerged by randomness, or if there is a final cause on it. And well, this led to discussions about the existence of God and things like that. And so this was avoided by science during many times. People in biology created a concept of teleonomy, which is more like the same thing of teleology, but trying to escape from this necessity of having God as is in the part of the equation. But the final explanation came to us only with cybernetics. With cybernetics, we could have an explanation for motivated behavior that doesn't require any kind of transcendental ideas to be understood. And in this paper from Rosenbluth, Wiener, and Bigelow from 1943, Behavior, Purpose, and Teleology, they could clearly show to us that there is a motivated behavior. They call it purposeful action that is directed to the achievement of a goal, a final condition in which the object affected by the action reaches a predetermined condition. And how this happens? Not at all in a difficult way, using a negative feedback loop control system. That's in the basics of cybernetics. Okay. Later on, Michael Bratman published this book, Intentions, Plans, and Practical Reason, and showed us that what gives an action this label of intentional action, an action that is made on the world intentionally, with an intention, a motivated kind of behavior, is the existence of a plan. So if there is a plan before its execution, then we can say that, oh, there is a motivated behavior inside it. Okay? So things are clarified, and we can understand how these things work. Well, this is a very simple scheme for us to understand how is it possible to have motivated behavior. We have here a sensory input. We need to have a representation of the present, what is happening right now at the environment. And this is a representation of what is going on here at the environment. There is here what we call a representation of a desired future. So this is where we want to achieve. We calculate the difference between these two, and we use the distance between the current present and the desired future to drive here a reactive behavior that actuates in the world and make a change at the environment. And this creates a feedback loop, a negative feedback control loop, and it works. Am I saying something different here? No, you're not saying anything too much strange here. This happened, for example, in a thermostat inside our refrigerators. Okay, we have here a set point, the temperature that we want to achieve inside the refrigerator. We have a sensor that measures the temperature of the refrigerator, and then we do this, and so a simple thermostat can be called a motivated behavior. Oh, not so interesting, not so difficult. Something that has been studied by control theorists 40 years ago, okay? But this is interesting that we are treating here a different phenomena. And now we need to see how this happens within our mind. And this is the interesting thing, okay? So, if we can understand what is a motivated behavior, then we can try to understand what is a motivational system. A motivational system can be seen as a module within a cognitive architecture that is responsible for determining the behavior of intelligent agents based on cognitive models of human motivations. And then the things start to become interesting for us. Why? Because now we are talking about how we work, how we do the things that we do around us. And then we need to go to psychology. And psychology has a model, a cognitive model for our motivations. And the most ancient model for us is what we call here the Hull's drive reduction approach, that is based on the motivation theory from Clark Hull. Okay? Clark Hull identifies the origin of the behavior in a set of internal needs. So you're talking about needs that we as animals or as human beings that we have within us. Okay? We have these internal needs. They are ontogenetically inherited in the sense that we are born with them, probably, or we might have developed these needs during our life. So there are needs that I have today that I didn't have when I was a baby, so they could evolve in time. But the fact is, our needs govern all motivated actions that we do in the world. Okay? So these needs, they provide the motivation in the behavior generation. And the mechanism is quite simple. It's not too complicated. The idea is that we have these needs, okay? And these needs are going to be measured, okay? They will be measured. And they will give rise to what we call drives. Drives could be seen as the need's degree of dissatisfaction. Okay? For example, I have a need for energy. Okay? I need to have energy. I have this need. This need is embedded in my mind. And if I have this need for energy, I will have a drive that will increase if this need is dissatisfied. What does it mean? Well, probably all of you, when we approach midday, for example, we will have this drive that is going to say, oh, you need to look for food. Okay? Why? Because this need of energy is not being satisfied internally by our organism. I need to do something. And what is this something? It is what we call an automatic behavior that necessarily, in this Hull's theory, create a drive reduction. So it needs to provide a satisfaction to our needs. So what happens? Well, my energy drive increases, okay? I say that, oh, I'm hungry, okay? And then what I do, I look for food and I eat. Okay, simple as that, nothing too elaborate. But the interesting thing is that, well, these drives, mechanisms, they work in us in every kind of motivation that we have, in the many needs that we have in a given specific point. Okay? And then the things started to become more complicated because if we think of one drive only, it's a simple mechanism. But we don't have only one drive. What we have is a full hierarchy of drives. Okay? This is a well-known Maslow pyramid of hierarchy of needs. Maslow was also a psychologist in the 50s, and he created this idea that we have different kinds of needs, and that these needs, they receive some kind of priority in this hierarchical way. Okay, so basically here we have more physiological needs, the needs to breathe, to have food, water, shelter, clothing, sleep. We have, if these needs are quite satisfied, then we are going to seek for higher level needs, safety and security, then love and belonging, self-esteem, self-actualization, and there are a new version of Maslow that talks about self-transcendency. We need to transcend our limits and go beyond what we are capable right now. Well, Maslow theory has been a lot criticized within psychology. Why? Because Maslow says that, well, this pyramid is fixed and it is the same for everybody. And psychology starts using this, for example, to try to create policies in jobs and things like that, assuming that there is a fixed priority. And psychologists later discovered that it's not fixed and it's not the same for everyone. So people can have different priorities. But anyway, this idea from Maslow is quite interesting for us to observe the complexity of it. But the problem in Maslow's proposal is this argument against the universality of the hierarchy. We cannot say that this is universal. For example, here is another author, Kenrick, that creates a quite different organization and set of priorities. And, but it insists that there is a priority. Oh, you're just giving us the wrong priority. But I believe that it's not exactly the point. Well, even though with this criticism, Maslow's considerations can be used here. And we are using Maslow's idea only in the sense that the number of needs increase, more difficult is to find actions simultaneously satisfying many needs. Because these needs can be contradictory, you see? Well, I am here and I'm looking to a bar of chocolate in the table, okay? So probably if I am hungry, I would like to eat this bar of chocolate. But this bar of chocolate is not mine. I don't know who is the owner of this bar of chocolate. So there are two different needs being addressed here. My hunger to eat the chocolate, and what I call the social needs, the needs that we have to be in a society, and I need to not go against the rules of the society, and so there is a conflict. I need to see how I'm going to solve this conflict. If I have one action driving me to pick the bar of chocolate, and another action say, don't pick because it's not yours, well, what should I do? Okay? So I need to have a priority. So needs form a hierarchy, yes. Some needs might have priority over others, and some needs have a bigger priority which are satisfied first. Okay? So now this priority is what gives me a difference. So depending on who is doing, someone will be there and pick the bar of chocolates. Another person will not, okay? Depending on the priority. If the person make a bigger priority to the social needs, then you do something. If they give a bigger priority to hungry, so they are going to do a different thing, okay? But some points still require investigation. For example, there might be unique hierarchies depending on an individual. So each individual will have in itself its own priority of needs, and then we can have a discussion on the limits of free will, if we really have this thing that we call free will. My idea is that, more or less, I would say that our free will limits itself to our ability to choose among the many needs, but nevertheless, I will be always tied to my needs, cannot escape from them, okay? What I can do is to give more priority to one need than to another need, but nevertheless, there will be one need forcing me to do something in the world, okay? Well, these hierarchies might change during existence. So can I change myself? If when I was young, I was doing wrong things and made a lot of mistakes because my priorities are a little bit different, okay? And now that I have some age, I change my priorities. Well, probably yes, but we need to prove that. It's not proved. Is it possible to create new needs along the creature's experience? Well, our common sense says that yes. For example, after the smartphones and computers appeared, we created an interesting need to constantly be looking to it. So that was a need that didn't exist 10 years ago, let's say. Okay? So again, I say that possibly it's possible to create new needs along the lives of a creature. But how? How these needs appear, how they start to become more or less important in our lives. So there's a lot of you here, you're listening to me, okay? But there are some of you that, oh, I need to see something at my mobile, okay? And this is one of these needs that I'm talking here, okay? How they appear and how I control needs like that. Well, besides drive reduction thesis from Who, there is a more newer theory about motivation, which is Bausmeister impulse theory. What is the difference between Who's drive reduction thesis and today impulse theory? The difference is that impulses are particular desires to perform particular behaviors on particular occasions. So, differently from drives, impulses have a beginning and an end. Remembering what I told you before, I see a chocolate bar in the table, and this gives me an impulse to go and eat that chocolate. And the interesting thing is that, well, as soon as I pick the chocolate bar and I eat it, the impulse ceases to exist, okay? Well, you can see that there are some resemblances between this impulse theory and the drive theory. The difference is that the drive is something that never stops. I will always have a hunger drive. It can be higher, it can be lower, depending on how much food I can get in the world, okay? But the impulse theory is a little bit different, because now it starts at some point and it ends in another point. It's just like if we took Drive's idea and made a discretization of it. And then this is what we call an impulse theory. So impulses might imply an evolution of Who's standard drive mechanism. Instead of drive reduction behaviors, this mechanism generates corrective impulses which, in being satisfied, reduce the corresponding drive. So we can see that these two ideas can mix together, okay? So we still have the drive, but instead of directly generation a corrective action to that drive, what I do is to generate an impulse, and this impulse is going to correct my drive, okay? So impulses are dependent on drives, and they depend also on a plan for their satisfaction. If I am here, I am looking to the chocolate bar on the table, I need to make a plan. Well, I need to move myself to the chocolate bar, I need to pick up the chocolate bar, I need to eat the chocolate bar. And as soon as I finish that, the impulse ceases, and probably my hunger drive has been satisfied, okay? So impulses from different drives compete to each other to be selected and executed. Right now, everybody of you here, you are having impulses. You are looking around, you are seeing a lot of things, and each of these things that you are seeing are giving you impulses in your mind, and these impulses are competing to each other, and then one of them is going to win, and this winning impulse is going to be the one that is going to be executed, and this is the motivated behavior for you in your environment, okay? Well, so the idea is more or less this one here, okay? We have many needs. Each of the needs had a drive. Each of the drives will generate a lot of impulses. There will be a competition between them. The selected impulse will be chosen, and then I will create a plan to satisfy this impulse, and this will lead myself to an action in the world. Okay, basically, this is the mechanism. Okay? Well, more or less. If we go to the theory about motivational systems, there is also something that we call the liking-wanting dichotomy. There are two kinds of things happening in our mind. There is the wanting, when I want something, so it is related to the impulses that I will be having. The wanting happens in the present, but it is directed to the future. Okay? If I want that chocolate bar in the table, I am anticipating a future where I have eaten that chocolate bar. Okay? So they specify a possible future to be reached, and it is related to the drives, impulses mechanism. So basically what we call a wanting is related to these drives, impulses mechanism. But we have something else. It is not just wanting. We also have this strange thing here, the liking. Well, there is a connection between liking and wanting, but what is liking? Liking is what we call the hedonic dimension, the idea of pleasure and displeasure. Well, pleasure or pleasures in a plural, okay? One or more dimensions, hedonic dimensions. There are different proposals in the literature, okay? Well, the difference between the liking and the wanting is that the liking is uniquely related to the present, right now. If I am doing something, I am liking or I am not. For example, you are here, you're listening to me. You are liking what I am telling you or you're not liking. Completely different, okay? It is now, just now. It is related in some sense to kind of emotional mechanism. You can see that clearly, okay? I'm talking about hedonic dimensions. Hedonic means emotion, okay? And they are related to the temporal difference on drives. Yes, because imagine that I have that chocolate bar. I wanted that chocolate bar. And I have a drive, a high drive that's saying to me that I need to pick up that chocolate bar. I come here, I eat the chocolate bar, and then this drive reduces. Okay? So what we are talking here, the difference, the temporal difference on drive, before and after I eat that food. Okay? Or dynamically delta drive, delta t. So at the beginning, the first kind of intelligent systems possibly only have this temporal difference on drives. But then evolution created something new for us. And what is this something new? Evolution created a specialized dimension, which is this liking. So why do I need to have the experience of going here and eating and knowing that there is a difference and then I can use that? Why I can't be embedded with this from the beginning? And this is the difference that evolution created. This is what liking is. The liking is a way in which I was born with a kind of a default understanding of things that will reduce my drives. So I don't need to experience them. I already know that from the beginning. So this is the liking mechanism, okay? Evolution further introduced specialized dimensions, and the goal is to serve as reinforcers in the drive reduction action learning. So the meaning of this liking thing is for me to learn these actions that are going to reduce my drives. Okay, this is the basic idea behind it. Well, this relates us to emotions. Okay, so in some sense, liking has to do with emotions. And what are emotions? How emotions relate to motivation? Because these things are very confused. Even in the literature, if you see people talking about emotions, you see that there is this connection between motivations and emotions, and it's not so clear what is the difference between them and what is the relation between them. So it's a big confusion in the literature. It's not a definitive view. Okay? If we go to the etymology of the word emotion, it comes from emovere, ex movere, to put out. Okay? This is the etymology of the word. And on the origins in the study on philosophy, it comes from a distinction between active and passive, action and passion. Okay? So this concept of passion in philosophy was gradually refined to reach the modern concept of emotion that is nowadays used in psychology. Okay? So from passion as a passivity to something external to the mind, it rises the concept of feeling, pleasure, displeasure, and appraisive reactions to possible courses of action. So this is the evolution of the concept of emotion. So from a mere passivity, emotions become an action of mind, guiding rational and intelligent behavior. Well, I'm not sure if there is some way, because it's going some microphone here to reduce a little bit the, yeah, okay. So this modern concept of emotion, according to Dixon, appears just on the 19th century as an abstraction to different concepts as, for example, appetites, passion, affect, feelings. And it was originally created by the Scottish thinker Thomas Brown around this date. So today, if we go to the literature on emotions, you see that there are four main perspectives. The first one comes from Darwin, Charles Darwin, that says that emotions are the result of an evolutionary process, and they are, in some sense, the behavioral expressions constructed during evolution. So Darwin has made an interesting study in many animals, showing how these different animals express their emotions. And for Darwin, emotions are just these expressions. Okay? For example, fear, joy, and things like that. Okay? The second view comes from William James. William James is a philosopher on the 19th century that sees emotion as effects in the body causing feelings. And this is also the idea that comes from Damasio. So according to Damasio, that follow James, emotions are things that changes our body states. Okay, my body states change in some way, and then my cognitive abilities detects that there is a change in the body and creates a cognitive consciousness of these changes in the body, and this is the emotion. So it's divided in a two-way mechanism. First, you have a change in the body, an expression of the emotion, and then you have the cognitive perception of this change. Okay? The third one is purely cognitive and comes from Martha Arnold from the 60s, that emotions are appraisals. So whenever I am appraising something, I am evaluating something, this should be an emotion. And finally, there is this social constructivist view that emotions are the cultural byproducts of learning social rules caused by interaction among human beings. So these are more sophisticated kinds of emotions like vanity or jealousy, things that require some social understanding for happening. Okay? Well, if we go to the literature of intelligent systems and cognitive architectures, you'll see that one of the most used models is this OCC model. This comes from Ortoni, Clore, and Collins, which published a book, I believe it was in the 80s or 90s, I'm not sure. It is called The Cognitive Structure of Emotions. And it deals with this appraisal-arousal dichotomy in emotions. So emotions for the OCC model are inner states with different intensities related to affects, appraisal reactions to situations considered to be good or bad related to events, agents, or environmental objects. The OCC model specifies 22 emotions implemented in terms of local and global variables with their values determined from rules applied to sensory information. So there are some emotional parameters and that's it. Okay? So this is one of the most important models for emotions. The second one is from Damasio. And Damasio has what we call the somatic marker hypothesis that bounds rationality with emotions. Okay, so the idea of Damasio is any intelligent action is in some sense related to emotions. We need a body in the process, and there is a distinction between emotions and feelings. So emotion is a body modification due to an external stimuli, following that idea from William James. Okay? And a feeling is a cognitive counterpart of the emotion appearing after the consciousness perception of the emotion. He divides primary emotions that are experienced since childhood, fear, joy, sadness, anger, and secondary emotions that are learned along the life cycle of an individual, jealousy, guilty, pride, and things like that. Okay? There is a third perspective on emotions, okay, that comes from Simon and Aaron Sloman. Emotions are alarms. This is what they say. Okay? So it is a process related to the motivational mechanism. Simon was the first in 1967, saying that emotions are interruptions. So critical situations might change a creature's goals, causing an interruption. For example, if a predator appears, this might cause the interruption of an animal's current behavior and the generation of a new goal in order to escape from the danger. So imagine that you are an animal and you are eating in some environment, so your motivation is to eat, and then a predator appears, and the appearance of the predator causes you an emotion, an interruption of your current motivation. And then you are changed to an altered state, and you need to do something else. You need to escape. You need to run, because otherwise you are going to die. Okay? Interruptions might be caused by an imminent danger, but not just an imminent danger. It could be a remarkable opportunity. If you just discover that, oh, I am here. I have good professors here. I have this opportunity of talking to them. This could create you emotions in a good sense, not to escape, but to take the chance to use your time and talk to this professor, to learn or to present yourself, and then this is a kind of interruption like that. Okay? Sloman's idea is a little bit different from Simon. He says that emotions are attention filters. He created this attention filter penetration theory. And differently from an interruption, just like in Simon, he presupposes a momentaneous disruption in the behavior with the possibility of returning to it lately. Okay? After the critical situation is over, I can return back to my past behavior. So Sloman used the term alarms. Alarms that are triggered by the danger or by a remarkable opportunity that appears at the environment. Okay? And there is another view. That is the view from Lola Canhamero and the modulation of motivations. Well, Canhamero proposed an emotional system where emotions work as modulators with the definition of synthetic hormones affecting homeostatic processes associated to the needs of a creature. There is a motivational mechanism which is independent. Okay? This is a modification in a creature's body variables that gives rise to drives, just like in the Hull's idea, triggering an action aiming at the reduction of these drives. So here we still don't have emotions. And to Canhamero, emotional mechanism is independent from the motivational one, but affects it. The idea is that in critical situations, the detection of these critical situations trigger the release of hormones, which cause a modulation in the drives. So there is a change in the value of these drives due to this mechanism, making some of them more intense while others are attenuated. So you can see that we have different kinds of emotions. Okay? So what we are proposing here, okay, yeah, probably you can hear me. So we have a kind of a unified view, a view in which we have a motivational system based on drives and impulses, and emotions can be seen as a result of an evolutionary process. And differently from the others, I am proposing one thing more here. I am proposing that the internal motivations of a creature are communicated to other creatures by means of their expression in bodily modifications. Okay? So we can have two creatures, for example, reptiles, that don't have emotions, but they have a motivational system. They don't exhibit anything. They don't have a behavior to show, but they have motivational states. Okay? Let's try if it works now. Good. Okay. And so emotions are necessary, are not necessary for the regular working of the motivational system, but they are affected by it. They just appear in the evolutionary scale in animals with a limbic system, birds and mammals, and they are a strategy to communicate emotional states that can be useful in social situations like collaboration, cooperation, and competition. And that's the difference that you have, for example, from earlier animals like reptiles, for example, where you don't find this collaboration too much, to birds and to mammals where these social interaction starts to appear. Okay? It is the source of confusion between motivations and emotions is that because an emotion, according to our view, are messages representing the motivational states, they are misleaded by the own motivational states. And we still need to finish with this idea of hedonic states. Well, they are used as rewards or reinforcements in the learning of actions required for drive reduction in the motivational system. And our hypothesis is that there might exist different kinds of rewards associated to the different creature needs. Okay? So this is, in some sense, that evolution that I've shown us. At the beginning, we have the sense, we have the drives, we have the reinforcements, we have this delta drive, delta t, and we have the needs. Okay? And then evolution created hedonic dimensions, avoiding this more long trajectory. Okay? And so we started to have hedonic dimensions that could be used for the learning of actions. Later on, we just created the idea of perception. We are able to discover objects around us. And so the mechanism started to become a little bit different. And finally, this is the final architecture that we can understand that can be used today inside cognitive architectures. We have the sensors, we have the needs that give rise to drives. There is the delta drive, delta t. There is the hedonic dimensions creating the rewards. The rewards are selected with the percepts. The percepts by themselves, based on the drives, they propose a lot of impulses. There is a choice of an impulse, gives rise to a plan, to an action, and this action goes to the world. Okay? This is the set of actions from where the plan serves itself to creating its plan. And here we have what we call emotion. So it's the communication of these internal states to the output such that I can communicate with other creatures. Okay, and just to conclude, this is a kind of a summary of this unified view that I have presented to you. We have a model of experience as this triple of SDR, sensors, drives, and rewards. Experience can be integrated in the form of percepts embedding this SDR. Okay? And motivated actions can be learned using reactive plus original actions, plus these rewards using a mechanism like reinforcement learning that you probably are very much aware that are used in deep learning and things like that. We can also use affordances for the generation of impulses, able to satisfy the landscape of drives. And the choice among a repertoire of impulses can be based on a hierarchy of needs that are probably unique and dynamic to each creature, differently from what Maslow tells. And then we are going to make a schedule of the motivated actions to generate plans, and emotions are used as a mechanism of communication of motivational states, allowing the appearance of complex social behaviors. And so, basically, this is the story that I have to tell you today. I know that it is a little bit more conceptual than programmatically, but I can tell you all those ideas, they can be turned into code, okay? And all those, not all, but most of these cognitive architectures that I have shown you before, some of them, they have mechanisms for motivated behavior and create motivational systems. Some of them do not, okay? And maybe this is something that you need to take in account when you are choosing the cognitive architectures that are wanting to use to create our intelligent agents. And that's it. Thank you very much.